Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. In this video, I will show you the procedure for hypothesis testing. Before we proceed, I would like to mention that the hypothesis that we are going to test in this session is hypothesis for one sample. Okay. Hypothesis one sample test. Okay. Why we call it one sample test? The reason is simple. Okay. Actually, we have one group of population. Okay. One group of population. Okay. Let's say these are the items in our population. Let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's say we have here, let's say 15 is the population, one group. So from this one group, we are going to take sample. Okay. Let's say we take this one as a sample, we take this one as a sample, we take this one as a sample, this one, and this one. So we have 1, 2, 3, 4, 5, 6. All these, the red one become sample. 1, 2, 3, 4, 5, 6. One groups of sample. Okay. Here, if we calculate the mean, we have the population mean. And here, if we calculate the mean, we have the sample mean later on. Okay. So this is the reason why we call it one sample test. A group of one sample taken from one group of population. Okay. Okay, now I will show you step by step of how to do the hypothesis testing. Okay. Okay, in hypothesis testing, first that we have to understand the scenario first, and then we will develop the hypothesis. Okay. Let's say there is a claim from government officers saying that the mean for TV set in home, for example, is 3 units. This means that basically it's mean equal to 3. Okay. With for example, here we have another information with the standard deviation of population, for example 0.8. This is the additional information. So first we have to know the situation. Okay. Once we know the situation here, the first step is that we will develop the hypothesis. So we have several options. Okay. First one, basically, of course, the hypothesis null. Hypothesis null refer to the status quo or refer to the historical value or refer to the common belief or the standard. So this mean equal to 3 basically is the historical value or the status quo, the claim made by the government officers or the belief by that particular party. Okay, so the claim is the hypothesis null, which is mean equal to 3. Mean of TV basically equal to 3. Now, hypothesis alternative is the opposite of this. This is the hypothesis that we are going to prove. Okay, we are going to prove, and will be opposite of hypothesis null. So here basically we have several options. Okay, for example, we may have option number 1. For example, it can be mean not equal to 3, opposite of this. Okay, or if you have and different ideas, the second option is that mean, for example, less than 3, meaning that you believe as a researcher the mean for TV set in home less than 3, or okay, the another option, the third option, mean less than 3. You can choose which one that you more prefer. Okay, some researchers may choose this, or they may choose this, or they may choose this based on their own reason. Okay, let's say, okay, we are choosing this first scenario. Here, mean not equal to 3. It can be more, it can be less. Mean not equal to 3, meaning that it can be more than 3, it can be less than 3. So that's why, okay, when you draw the normal distribution, you will have two areas here. Okay, here basically on the right is basically more than 3, on the left basically less than 3. Okay, this one we call it 2 till test. Okay, now if for example you choose this alternative hypothesis, mean less than 3, so this will be the diagram. Less than 3 meaning that on your left, this will be the area. For more than 3, okay, the area will be on your right. So this is important for us basically to identify the critical value electron. We will find the critical value, what is the value here and here, or what is the value here, or what is the value here. Then we can make decision whether we can support this claim or we cannot support the claim. So this is the basic, okay, developing the hypothesis null and hypothesis hypothesis null and hypothesis alternative. For the hypothesis alternative, we have several options. It can be option number 1, 2 till not equal to 3. It can be more, it can be less. Or hypothesis number 2, which is directional, which is here, for example, less than 3. Or hypothesis number 3, more than 3, directional. Okay, so the graph will be like this, the curve on your right. Okay, so in this example, for example, let's start with this. Let's say now we believe that as a researchers, we believe that the mean not equal to 3. It can be more, it can be less. So we are going to prove our belief. Okay, so the first step is already done, which is state the hypothesis. Okay, the second step is we have to identify the significant level. Okay, we have to identify the significant level. Okay, how to identify the value of significant level? Remember, previously we have learned, okay, the confidence level. Here basically we know that, okay, we have the confidence interval. This is the upper value, this is the lower value. Here is the confidence level. Okay, with the confidence level, for example, 95% confidence level, okay, we will get the lower value and the upper value of the interval. Okay, so now the significant level, the formula is very simple. Significant level basically is 1 minus confidence level. So in this example, for example, here we have 95% confidence level. Okay, so 1 minus 0.95. So the alpha, the significant level is 0.05. Okay, so this is the value for significant level. So remember that since the sign here is not equal to 2 tildes, we will have 2 area on the right and also on the left. So the alpha level here, this is the alpha. Okay, this is the alpha, this side and this side. Since we have 2 area, both right and left, the alpha value is alpha divided by 2. This one also alpha divided by 2, which is here the area is 0.025. Same thing here, this area is 0.025. So this is the second step. Okay, identifying the significant level. How to get it? Some they straight away give the significant level. If they not give you the significant level, they will give you the confidence level. Based on the confidence level, we can calculate the significant level. Okay. At the same time here, we have to identify the size sample. Okay. Here n basically, for example, here n, the sample size we have 100. So we will use this information to calculate the critical value. Okay, so this is the first 2 steps. Now we are ready to go to the third steps. Okay, the first is stating the hypothesis, the null and the hypothesis alternative. The second one is that identifying the significant level. Sorry, the third step is basically to determine the appropriate technique. What kind of statistical technique that we are going to use to test this? Okay, so the third one is that determine the right technique to analysis. So now, since we are given the population standard deviation, okay, basically we know the population standard deviation, so we are going to use the Z test. Okay. If we do not know the population standard deviation, we are not going to use Z test. We will use the T test. Okay. So let's stick to this example. We are going to use the Z test because the population standard deviation is known. Okay. This is number 3. Number 4. Okay. Step number 4. We will identify the critical value. Okay, these are the things. This is the normal distribution. Okay. Remember, our hypothesis alternative mu not equal to 3. This sign shows that we have two tails. Okay, so that is the reason why I draw like this. Now we have to know the value here, critical value, the upper one, and also the critical value, the lower value here. The lower value of critical value and also the upper value. So why we need to identify the critical value? The reason is simple. Where, for example, we want to determine later on, okay, any value, the statistic value that we will calculate later that fall in this area, okay, the dotted area, the decision is that we will accept the hypothesis. If otherwise, if the statistic value that we will calculate later on fall in this region or in this region, we will reject the hypothesis. So this is the decision rule. Okay. When later on we will calculate the statistic value, any statistic value that fall into this region, the dotted one, we will accept the hypothesis. Okay. If the statistic value fall in these two regions, we will basically do not accept the hypothesis now. Okay, so the function of critical value here is to differentiate which area fall under acceptance region. This is what we call, okay, this here basically we call acceptance region. This area we call non-acceptance region. Here also we call non-acceptance region. Okay, so this is the thing. Now, what is the value here? To know the critical value, it is easy. We just look the Z table. Look the Z table. So as we have learned last week, with 95% confidence level, okay, the Z value basically, okay, the Z value basically plus minus 1.96. So here is plus 1.96. In the middle here is 0. Here is basically negative 1.96. Okay, to make it clear, this is the value. here is the value. Okay, so this is the 4 steps: identifying the critical value. Okay, then we move to the step number 5. We will calculate the, we call it test statistic value. This one we call it critical value. Okay, next we are going to calculate the test statistic value, which is step number 5. So let me redraw first, okay, because easy for you to understand later on. These are the critical value that we have calculated, okay, from the table. Z basically plus 1.96, non-rejection, non-acceptance region. This is minus 1.96. Here in the middle is basically 0. Okay, now this we call critical value. Okay, now step number 5, we are going to calculate the we call test statistic. This is the formula. Z okay, this is the formula for test statistic for Z value. Okay, so for example, based on the sample, we got given here x bar, for example, okay, x bar 2.84 minus the mean value here 3 TV set. The sigma is 0.08. Okay, sorry, 0.8, and the n is 100. So the test statistic Z value, we got negative 0. So negative 2.0. Negative 2.0. Okay, now in order to decide whether the hypothesis can be accepted or not accepted, okay, we have to compare this value. The test statistic compare with the critical value. We have to determine where this value located or fall, okay, in this normal distribution. Okay, first we look at the sign negative, so we know that this will be on our left side. Okay, 0, and then bigger. Okay, negative 2. Here is negative 1.69. Negative 2 will be somewhere here. Okay, so we know that this area, okay, any value, any statistic value, okay, fall under this region. We call it here acceptance region, meaning that we are going to accept the hypothesis null. If fall in this area, non-acceptance region, meaning that we are going to not accept the hypothesis null. Okay, so in this example, this value fall in this area. So basically, okay, meaning that we cannot accept the hypothesis null. Okay, this basically we a hypothesis null accepted. Here basically not accept hypothesis null. Okay, so if we not accept the hypothesis null, meaning that we accept the hypothesis alternative. Okay, so that is the decision that we made. Okay, so what is the conclusion? The conclusion is there is sufficient evidence that the mean number of TV is not equal to 3. So that is the final conclusion. So I repeat, the conclusion is there is sufficient evidence that the mean number of TV is not equal to 3. So that's all the basic steps in hypothesis testings. Hopefully you can get the basic idea of what is hypothesis and all the steps that should be taken before we make the final decision and come up with the conclusion. With that, thank you very much.